you have an n by n by n cube. So if you have this cube right here, and you're trying to look at the cubes that you can't see, you need to look at the cubes that aren't on this layer, the front layer, the back layer, this layer, or anywhere around, right? So you're shaving off the bottom layer, you're shaving off the top layer. Good job at it. Not connecting, shave off the back. So if you shave off 1 unit each side, if you shave off 1 unit off each side, if this is n going across, going all the way across, what's the distance from, let me get a different color here, what's the distance from here to here? N minus 2. The shape of the cubes, the overall shape of the object in the center that you can't see is a cube. It's not an n by n cube because that's the whole cube. The inner cube that you can't see, what's the dimension of that cube? N minus 2 what? Cubed, exactly. It is n minus 2 cubed. So, but how many cubes are in the whole thing total? There are n cubed total. So if you start with n cubed total and you take away, so this right here represents the cubes. And this represents what? All the hidden ones. So if you take away all the hidden ones, you get all the visible ones. Exactly. Good job. All the visible ones. Did you simplify this?
Yes.
Yeah, so it looks like a cubic, right? It looks like a cubic, but is it really? No. You end up with n cubed minus n minus 2 times n minus 2 times n minus 2. That's going to be, and I'll put that in parentheses. How do you multiply out something like that? This is just polynomial multiplication. How do you multiply something like that? Do one pair first, exactly. So you end up with n squared minus 4n plus, so I multiply the first two. In this case, any two of them together will be the same thing, right? And now what do you do? Multiply everything again, yeah. End up with n cubed minus 4n squared plus 4n minus 2n squared plus 8n minus 8. But what's in front of that bracket? Minus sign. So you get n cubed minus n cubed plus 4n squared minus 4n plus 2n squared minus 8n plus 8. What cancels? The n cubes cancel. And can we combine some stuff? Yeah, so you end up with what? 6n squared. So we got that one. And that's 6 minus what? Plus 8. So that's the number of what? Visible cubes. Number of visible cubes. Can you factor that? Well, here's a hint. Everything is factorable. Everything is factorable. Is it factorable nicely?
Yes. No.
What can you factor? What's the easiest thing you can factor out of each of those? 2. So you get 2 times 3n squared minus 6n plus 4. So it would be 3n and n. Is this entirely necessary? No, this is the final answer, but factor just to practice a little bit of factoring. Is it factorable? What do you think? The blank two numbers have to multiply together to get what? 4. They have to multiply together to get 4, right? So it could be what, 2 and 2? Is that true? But if you do 2 and 2, does it come out to be negative 6 in the middle? No, it really doesn't. How do you check to see if it's nicely factorable? You check the discriminant, which is b squared minus 4ac. In that case, it's going to be negative 6 squared minus 4. What's a value? What 3? What's the c value?
4.
So that turns into 36 minus, what's 4 times 4?
16.
What's 16 times 3? It's equal to negative 12. So if you get a negative sign underneath the radical, the answer is going to be...
No.
The answer is going to be no, yeah. It's going to be only imaginary roots, so it's factorable. Therefore, not nicely factorable. So you leave it just like that. You could factor this out, maybe say it like that. But it's a quadratic. It looks like a cubic, but it's really a quadratic because you're killing that cube. You're killing the cube. Okay, that's a nice one. That's the x value. of the vertex, and then you just plug the x value of the vertex in. Actually, it's 2 because 3 times 1 squared is 1. 3 minus 6 is -3. -3 plus 4 is 1. 1 times 2 is 2. So the vertex is at 1, 2, if you care to know that.
Okay.
Just because it has a nice vertex, does that mean anything else is nice about it? No.
Y equals
y equals
ax squared plus b.
ax squared plus. So to solve for this quadratic, we need to solve for a, we need to solve for b, and we need to solve for c. We have 3 blanks, so how many equations do we need at least? 3. We need at least 3. Can we form 3 equations? Sure. How about with this one? At 1, 1, we know it's 1 when it's 2. A times 1 squared plus times 1 plus c. Right? There's one equation. What's the second equation we could generate? We know it equals 0. 1. You have a to what? 3 squared. Yep, you both said correctly either one, right? Plus b times 3 plus c. And we also know it equals 0 when a times what? -2 squared plus b times plus. How many equations do I have?
3.
So what method could you use at this point to solve for a, b, and c? Now you could use, if you wanted to, you could use substitute. Absolutely. Substitution time. Yeah. Did you randomly pick that 0.11? What's your feeling about whether you're going to get nice numbers for a, b, and c? Probably not. It would be lucky if we did. It might be something decent, but the point is you can't be guaranteed to have some nice thing. Okay, that's one way to do this, right? Okay, so we set up a system of simultaneous equations. That's one way to do it. That is only one way to do it, though. What's another way to do it? Anybody have an idea? Yeah. Yeah. Yeah, this is something that's going to take a little bit of explaining, depending on, it really depends on what you did in Algebra 2. What's a good letter? If t is a 0, what is it for something to be a 0? T0, a point on the graph. Means, yep, you're right. What has to be a factor of your, it's any value you want. Ready? How about this? Let's just do this. Let's make it more specific. Let's say it was, let's say 6 is a 0, then 6, 0 is a point on the graph. Do you agree with that? So I'm just going to replace this. Instead of saying 6, I'm going to say, well, if it ever decides to erase, I'll call it t instead. What value could t be? What value could t be?
Any value.
Thank you.
Real value.
Any real value. Very good. Any real value. So if t is a 0, meaning the graph crosses at t0. So how many zeros does this have? 2. -2 and at x equals 3. -2 and at x equals 3. Yes. Here's the point, though. This is a big one. If t0 is a point on the graph, then x minus t must be a factor of function that you're graphing. Why? Here's why. Let's say I had x minus t times some huge equation right here, or any equation. And that was our function of x. Great. So we have some function that's x minus t times something huge. What happens no matter what if I plug in t for x? If I plug t in for x, what's t minus t? 0 times anything is 0. So once again, is it supposed to be a 0? Yeah, I told you that. I said if t is a 0, then you know that t0 is on the graph, which means that, let me finish my sentence, which means that x minus t must be a factor of what you're graphing. 0 times anything is what? 0. So let's say I asked you this. Let's say I gave you a polynomial and I told you that there were zeros at -5, -3, 2, and 4. How many zeros? Well, we know there's 4 of them. Maybe there's more. But what have to be factors of this polynomial? Someone raise their hand and tell me one of the factors. Will, what's one of them? x5 has to be one. Yep. What's another one? x minus 2. What's another one? x plus 3. And what else? X minus 4, exactly. Hey, if I multiply these all together, what do I get? I get an equation. If I multiply all those together, I get an equation. What does that equation pass through? 2 and 4. If the only thing I've given you is the zeros, do you care what else it does? No. You have fixed it to those points, though. Could I put pi out front if I wanted to? Yep. If I do, could I put 18 in front? Whatever constant I put out front, will that change the zeros? No. Why? Any number times 0 is still what? 0. It doesn't matter. So let's go back to our original equation. It said it's a quadratic, and what are the zeros? I think it was at negative 2, 0, or was it negative 3? Negative 2, what? 3, 0. So if those are zeros, can see what's one factor? X minus 3, and what's the other? Plus 2. And what happens if I multiply these together? You have an equation that goes through negative 2, 0, and 3, 0. Could you turn this into any function that abides by that? You could put a constant out front. You could pick any constant you want. What's the nicest constant to pick if you had to pick one? 2. How about 1? Because you don't have to write it. You could make it negative. What happens when you make it negative? It goes from up to down. That's it. Do the zeros stay the same? Yeah, they get tacked together. So let's graph a few of these so you see what I mean by this. I like the zoom box. Let's pick a nice zoom window here. So let's say we went from, let's go like this. I'm going to press enter here. I'm going to go down below.
It zooms in on the box.
That's what zoom box does, yep.
That's awesome.
It helps you when you either can't read the graph or you want to do something a little creative. It tends to be a little bit of clicking, more so on this one. And I really should stop clicking or it's never going to stop. Like I'm not clicking right now and it's still moving. Good job, Josh. Okay, I press enter on this. So here's part of it. Now if I put a different coefficient in front, what's the only thing that should change? The steepness, right. So for example, if I do this, instead let's make it 0.5 times, and watch this, vars, y1. You see that? y1 is that function, so I graph this, look what's going to happen. Oh, there's the first function. Look what happened. Did the 0 change?
No.
No, it did not.
Is the vertex the same?
No.
No.
The vertex, it'll be shallower, so the vertex will not stay the same. So I made it like, I don't know, 0.1, and go vars, y1, and I graph this thing, make it even shallower. But does the 0 change? No. 0 times anything is 0. How would we flip these upside down? Make it negative. So let's say we did, I don't know.
-1.
Yeah, exactly. How about negative 0.3 times, and I see I skipped one, but that's okay. As far as I know, it's okay. This thing, look what it did. Again, did it change the 0? No, it did not. Okay. I don't know why it's not doing this. So we go y equals. Now it chooses to freeze. That's fine. Okay, I got the graph though. It doesn't change. So let's say you didn't any of these methods. Let's say you just had your calculator. What would you do? Yeah.
Just enter 2 of the points and make a third, and enter.
And then do what?
And then find the.
What's it called?
line.
The regression model, right? And if I told you it's a quadratic, just use quadratic, right? So for example, we chose 1, 1 as our point. Let's go back in here, and what do we go into? We go to stat.
Edit.
Yeah, let me pause a second. We record, and let's go to. So I go to stat, edit. I need to clear those lists, right? Clear, enter. Clear, enter. And what was one of the points? It was negative what? Negative 2 and 0, right? And the other one was 0, and it was negative 3, right? Is that correct? And then we picked 1, 1, right? And 1. So then we go back to the main screen. And what do we do?
Clear.
Well, yeah, clear. I like that. That's fine. That's fine. That's fine. So we do stat, calc, and we told you it was quadratic, so you put quadrag. And after you pick quadrag, vars, y-vars, function, y1. And you hit enter, it runs the quadratic regression. Hey, look what the r-squared value is. 1. What does that mean?
It's perfect.
What does that mean?
It's
What does that mean?
same.
It goes through every point. Thank you. That's exactly what it means. Thank you. So we do that, and now it gives us those values, which are nice fractions, right? By putting that y1 there, it automatically entered it in. Actually, I got back to mode here. Mode, function mode. Oh, look, there it is. Yay. Am I going to turn off y2? Let's clear that. And zoom, how about, which zoom mode should I pick? Standard or what?
0. Stat.
Zoom stat. It's 9. Thank you. And there it is. Now, here's the thing. If you can go back in here, let's turn on the plot right here. Let's graph that. There are the 3 points. Look what it did.
And then you can find any other.
Exactly. Now, could you do anything else?
Yes.
You could do any other point. Exactly. I've never run the regression when I've had points that don't make it a function. It will give you just some error otherwise. Yes.
What is the L3 column when you do stat plot? I mean the stat list.
I think you can have more than one list. By default, it uses L2, but you can see table right here.
Oh, yeah.
But you need table set, which is right here above window, right there. So you go second table set, and we need to say what do we want the start value to be. So for example, I don't know, like -4. Delta table means what's the increment going to be? Let's say, I don't know, 0.25, like every quarter.
Right.
Sound good? And then we just go to table by hitting second there. Look what it gives you.
Okay.
And you can keep on scrolling through if you want.
Mhm.
It's helpful. And you will do this. This is something that will come up in other classes all over the time. Because in the future, sometimes you're going to deal with functions that aren't defined at a point. Like you can't plug the value in, but you can get infinitely close. You're going to look at limits in calculus. So the first time you look at limits, what are you going to do? You're going to make a table and look at it coming from the left. Like if the left goes 0.99999999999 and the right goes 1.0000001, what do you think it's going to? 1. If you're really, really close to the left side of 1 and you're really, really close to the right side of 1, what are you going towards? 1. So the first way you do it is you believe it. But is that algebra? No. But does it help to believe what you're proving before you try to prove it? Yes. It can help. It could also mean, what happens if you believe the wrong thing?
You're wrong.
You can maybe do a lot of, no, not necessarily. You're just maybe doing a lot of the wrong work. Time. It can take a long time. What's the second method we came up with? Yeah, use the factored form method. This is exact and super easy. What's our third method? Run a what? What do we call this? What is this? Using your calculator. Run a what? Run a cubic regression. But yes, you're running a step up. Running a cubic regression. You're running a cubic regression with, can you just do it with 3 points?
You have to have 4.
What happens if we ran a cubic regression with 3 points? What do you think the calculator is going to do?
Syntax error.
Yeah, maybe it would. What? Maybe change it to a quadratic, but the thing is, if we say cubic regression on these 3 points, can you write a cubic through any 3 points? Sure, but is the calculator necessarily going to choose one of the infinite number of possibilities? Like, is the calculator good at doing that? What do you think? No, a calculator is good at doing exactly what you tell it to do. If you tell it to find an equation and its methodology ends up telling it, well, there's a lot of them, is the calculator necessarily even smart enough to know that there's a lot of them? No, its method is probably going to go,
The closest one.
well, the closest to what? Like, if you don't have a starting point, if I said, get the closest to blah, 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 and you don't know what that is, do you have any idea what to do? No. My guess is, and this is total guess, the calculator will freak out if you try to run a cubic regression with only 3 points.
Can we try it?
Let's try it and see what happens. Ready? Just watch. Let's see what happens. Okay, so once again, so we get this on tape. We try running a cubic regression on 3 points, and it goes, no. No. I really think it should be more descriptive, but, you know, you can only hope. Okay. Area of polygons. How are we doing with that?
Good. Great.
Radicals. What do we think? Yep. Pythagorean theorem.
Yes.
Midpoint.
Yep.
Distance formulas.
Yep.
Applications of area.
Yep.
Multiplying polynomials.
Yep.
Volume and surface area.
Yes.
Modeling with cubic functions. Well, we just started it, right?
Yes.
We
What
just
is
start
modeling?
taking a situation and coming up with an equation that models that situation. You're coming up with a set of rules that govern that situation. So, for example, one very, very specific model would be, here are 4 points. Find me the cubic that goes through all of those 4 points. That would be a model that models the behavior of those 4 points. Are there real-life situations that are modeled by cubics? What do you think? what do we think? Real life situations by cubics. What do we think? It's a big world. What do you think? Yeah, there's probably something out there that is accurately modeled by a cubic. Are we always going to have models that come up with r-squared values of 1? No. R-squared value of 1 means
Perfect.
perfect. In the real world, do you get a correlation like that ever, really? No. Is it pretty much random chance or a really small sample size? Yeah. So it depends on the model, but the closer to 1, the better. So like 0.995, is that generally accepted as a good correlation? Yes. But remember, good is, hot, cold, high, low. That's all relative, right? Like 100 degrees might be hot for like the average temperature of a given city, right? But is 100 degrees, is that hot for the sun?
No.
The surface? No, not at all, right? So almost everything is relative. There are very few absolutes. So in this case, for modeling data, the models very rarely are going to have perfect correlation. Perfect correlation. So the first part of your homework is find a real-life situation modeled by a cubic. Find me one. And then part 2 of the homework is bring in a data set
Linear, quadratic. So
that could accurately be modeled by a cubic. You understand what I'm saying?
Yep.
That could accurately be modeled by a cubic. Find one and bring it in if you can. Bring in as much data as you can, but within reason. Do I want 1,000,000 points? No. Do I want 1,000 points? No. Like, try to find something within reason. Yes. So on your calculator, you need to do this. This is really important. So sometimes the R value, the R squared value is what you're asking about, won't show up, right? What you need to do is you go into, as far as I remember, you go into catalog, which is down on the 0. So you go second 0, and you get the catalog right here. And then you go down to D. You can jump down there by going alpha, little X thing right here, down there. Oh, didn't work. Let's see here. There it goes. Do you see DEEDI? See diagnostic on right there? You go diagnostic on, press enter, and then run it. Once you've done diagnostic on, as far as I remember, it will turn on the R squared value. If you run diagnostic off, the R squared value will turn off. So just remember that